We are asked to evaluate the integral of tan x cubed times secant x cubed. So if we take a look, we can see that tan x and secant x are multiplied together and they are related, so we might be able to use integration by substitution here. So we see that secant is an odd power, so we might be able to convert some secants into tan x, but the derivative of tan x is secant squared x. So we can't really substitute u for tan cubed x. So we can try to substitute u for secant x. And the derivative of secant x is secant x tan x. So maybe we can convert a tan squared x to secant x, and then we'll be able to have some form of secant x multiplied by secant x tan x, and that will hopefully be able to give us our integration by substitution. So let's see how we can rearrange this. So from our Pythagorean identity, we know that cosine squared x plus sine squared x equals 1. If we divide both sides by cosine squared x, then what we are going to get is 1 plus tan squared x equals secant squared x. So we can substitute tangent squared x with secant squared x minus 1. So if we do that, then what we are going to get here on the left-hand side is this tangent cubed x is going to be tangent x times tangent squared x, and that tangent squared x is going to be secant squared x minus 1, and we still have this secant cubed x dx. And now notice everything is in terms of secant, except for this 1 tan x, which is okay because that is what we want to use for integration by substitution. So we can expand, but we want to keep 1 secant x because we want 1 secant x tan x in here for our integration by substitution. So let's just rearrange this. We're going to multiply a secant squared into this parentheses. So what we're going to get into this parentheses is secant, so we only want to multiply secant squared x into here, so we're going to get secant x to the 4th minus secant x squared, and on the outside we are going to multiply it by secant x. We're also going to multiply it by this initial tan x, and our integral is with respect to x. So now we can make our substitution. So we have u equal to secant x. du is going to be equal to secant x tan x, secant x tan x dx. And now if we take a look at our substitution, we have every secant x equal to a u, and we have our du equal to secant x tan x dx. So we have successfully made our substitution and can proceed with computing our integral. So here we have u to the 4th minus u squared du. And if we continue simplifying, we have the antiderivative of u to the 4th, which is 1 over 5 u to the 5th, minus the antiderivative of u squared, which is 1 over 3 u cubed, plus c. And now don't forget to substitute in our final, or our original variable, which is x. So our final answer is 1 over 5 secant to the 5th x minus 1 over 3 secant cubed x plus c.